Hello, everyone, and welcome to the lecture for Chapter 1, Psychology's Roots, Critical Thinking, and Self-Improvement Tools. So I decided to stick with the textbook title, but here's really what we're going to be talking about for this lecture. First off, psychology is a science, then we're going to talk about the history of psychology and why we have this need for psychological science, followed by a little bit of research methods. So, how do we ask and answer questions in psychology, and a little bit on research ethics, very briefly. So, mostly sticking to the material that is in the book, but not really presenting it in the same way. And that'll be a theme that you see throughout the 8 weeks. So, first off, what is science? It's a question that we don't think about very often. We just assume we know what it is. But in general, science is an approach to inquiry that is tied to actual measurement and observation. So, one example depicted by a galaxy in the bottom left corner here is astronomy. Early scientists noticed differences in where the sun rose and set across different times of the year. They noticed different phases of the moon across the month, they noticed eclipses, they noticed comets, and these observations formed the building blocks of astronomy. Similarly, scientists have made incredible discoveries watching the natural world. So, observing the behavior of bees led to the discovery of what's called the waggle dance. So, this waggle dance allows bees to communicate the direction and distance of flowers, water, or potential new home sites. So, science begins with simple curiosity, and we see this example of the empirical side of science in these examples.
Honeybees have some fascinating abilities, among them being able to communicate by performing a unique dance. It informs hive mates where a newly discovered food source is located. Every cycle of this waggle dance roughly describes the shape of the figure 8. Let's rewind and look in more detail. The bee only waggles on a part of its route, the straight run, indicated here by the waved line. The secret lies in the direction of the straight run, or to be more precise, in the angle between the straight run and the perpendicular, which in this case is 90 degrees to the left. This tells the other bees that food is available 90 degrees to the left of the sun. If the angle is 60 degrees to the right, they'll be flying 60 degrees to the right of the sun.
Psychologists use the same scientific attitude and critical thinking to ask and answer questions related to human thoughts and feelings and behaviors. So here's just one example. This would be self-efficacy theory from a lot of Bandura's work that we'll talk about later this term. And here's just another example of psychological science in action. This is a classic study in psychology, a little bit about human nature here. So this was in 1956. Solomon Asch was interested in studying conformity. So the participants for this study were male college students, and they were asked to engage in a seemingly simple task. So an experimenter standing several feet away held up a card that had one line on the left side and then 3 lines on the right side, labeled A, B, and C. The participant's job was to say out loud which of the 3 lines on the right was the same length as the line on the left. So they went through 16 different cards, one at a time, and the correct answer was so obvious every single time that it was intended for the task to be a little bit boring. Except for one thing that Asch and his colleagues did. So the participant was not alone. There were 6 other people in the room who also gave their answers to this line judgment task, and also gave those answers out loud. But these other 6 people, although they pretended to be fellow participants, they were actually working for Asch. They were working with the experimenter, and the real participant was seated in a way so that he always gave his answer after hearing what the other so-called participants said. Everything went as expected until the 3rd trial, when out of nowhere the first fake participant gave an obviously incorrect answer. So that might have been amusing for the real participant. But then the second fake participant gave the same answer, as did the third and fourth and fifth. So all of a sudden, this real participant was in a tough situation. His eyes told him one thing that seemed very obvious, but 5 out of 5 people apparently saw something else. So these fake participants uniformly gave incorrect answers on 12 of the 16 trials. And 76% of the participants, the actual participants, went along with this incorrect norm at least once and gave the wrong answer. In total, they ended up conforming with the group on 1/3 of the 12 test trials. So even though we think something is so obvious, for some reason we'll just fall in line with what other people are doing. So that's one example of how psychology has used research and simple curiosity about human nature to drive the field forward. Sorry, had a computer freeze for a second there. Okay, so why do we learn about psychology? Kind of alluded to it a little bit here, but first, just to understand ourselves. We also may be interested in learning about other people or other groups. You may be curious about how could you influence others. So, for example, socializing children or motivating employees. Some people would like to learn a little bit about how to help others and improve the world, maybe doing effective psychotherapy. You might be interested in learning a skill that could lead to a profession, such as being a social worker or a professor. Maybe you're interested in learning how to evaluate the research claims that you hear about or read about. And maybe just because it's interesting, it could be challenging and it's fun. You don't have to only have one of these motivators. Often, students and professionals in this area learn about psychology for many different reasons. So now I want to shift gears and talk about the history of psychology a bit. And I'm going to go a little more in depth than the book does. Part of this is I want you to think about what others would fail to understand about you if they did not know your history. So we're going to go through these details in an effort to see or to help you see how the richness of what makes you actually you comes from an understanding of your past experience. So the good, the bad, the ugly, all of it makes you you. And the same thing applies when you're looking into any particular field of study as well. So the history in the text focuses on the relatively recent history of psychology, though if you were to take a course on the historical roots of psychology, you'd likely start as far back as the ancient Greeks. John Locke in the 16 to 1700s, Thomas Reid as well in the 1700s, promoted what's called empiricism. And that's the idea that all knowledge comes from experience. The work of Locke, Reid, and others emphasized the role of the human observer and the importance of our senses in defining how the mind comes to acquire knowledge. This then progressed to what's called psychophysics. And psychophysics is the relationship between the experiences of the senses and our external reality. A really important figure here, a German physiologist, Hermann von Helmholtz. It's a big figure here. So his work focused on measuring the speed of neural impulses as well as the physiology of our hearing and our vision. In part, his work demonstrated that our senses aren't perfect, so they're fallible, but they can still be studied scientifically. So von Helmholtz's work, as well as Locke before him, showed that our senses can and sometimes do deceive us. as the image on the slide shows. As we move forward in time, we get to the man often considered the father of psychology, and that is Wilhelm Wundt, even though he was actually a physiologist and philosopher. So Wundt helped establish and promote the field of experimental psychology. He was really a consummate teacher and academic, and he exposed countless students to the field. He opened the first lab in experimental psychology, and that was at the University of Leipzig in 1879. His work really focused on introspection, or identifying elements of consciousness scientifically. Perhaps his most famous work was actually completed in the area of reaction time. And what his work and his students showed is that consciousness could actually be studied in a scientific fashion. So you'll notice so far that I actually talked about several European, particularly German, researchers, but eventually the scientific study of psychology also gained ground in the United States. So that kind of started with Edward Titchener. And he was actually a student of Wundt's, and he brought some of those ideas to the United States. Titchener's work was referred to as structuralism, and this work was really interested in the contents of the mind and what the mind is. One of Titchener's students, Margaret Floyd Washburn, became the first woman in America to earn a PhD in psychology. Although, as your book points out, she actually should have been the second. Functionalism, so what the mind does, emerged as an alternative to structuralism, so that focus on how the mind is structured. Functionalism was promoted and expanded by people like William James, G. Stanley Hall, and James McKeen Cattell. So they're really focused on what the mind does. William James's book, The Principles of Psychology, so shown on the slide there, is widely regarded as one of the most important books ever written in psychology. And in it, James proposed that consciousness was not just something that could be studied by breaking it down into its component parts. Instead, it needed to be studied as an ongoing and continuous whole. One of James's students, Mary Whiton Calkins, went on to become the first woman to serve as the president of the APA, and she was the person who should have been the first American woman to receive a PhD in psychology. So here we have this rapid spread of experimental psychology, and G. Stanley Hall, another of the proponents of functionalism, later founded the American Journal of Psychology, which is the first American journal of psychology. He also founded the first psychology lab in the United States, and that was in 1883 at Johns Hopkins University. So now we have the first psychology lab in the US just 4 years after Wundt's lab opened in Germany. And it really spread like wildfire from there. So we had 40 labs started in the United States and Canada by 1900. So that's 40 labs in just 17 years. G. Stanley Hall was the first American to earn a PhD in psychology and the first president of the APA. Much of Hall's work focused on child development and education, and Hall mentored Francis Cecil Sumner, who became the first African American to earn a PhD in psychology in the US, and that was in 1920. And the last figure I mentioned with functionalism was James McKeen Cattell. He spent much of his career looking at individual differences. Cattell's work focused on the idea that intelligence is inherited and can be measured. His work actually sparked much of the debate about the contributions of genetics and environment in intelligence, and his beliefs about identifying and promoting society's most intelligent were akin to those of the eugenics movement, so selective breeding. So this is where I was talking about the good, the bad, and the ugly of your history help you understand where you are. This would be one instance of some of the ugly of psychology's history. Psychology's growth was prodigious in the first half of the 20th century and worked to incorporate many different viewpoints. Gestalt psychology was a great example of this expansion. So, Gestalt psychology is famous for the idea that the whole is greater than the sum of its parts. And this movement proposed that the mind is capable of processing multiple stimuli simultaneously as opposed to doing this work sequentially. And ideas from the Gestalt movement were or are often seen as a precursor to cognitive psychology revolution that we saw later on in the 20th century. At this time, we also have Sigmund Freud's work becoming more prominent, promoting the value of unconscious processing, which does tap into that simultaneous cognitive processing. The behaviorist movement, championed by psychologists like B.F. Skinner and John Watson, focused on that which was observable and measurable, thereby rejecting the idea that the mind could actually be studied. The ultimate goal for behaviorists was prediction and control of behavior. We had classical conditioning, made famous by Ivan Pavlov, another behavioral idea that lent credence to the notion that learning and behavior could be studied without considering the mind or consciousness. And it wasn't actually until the 1960s in the United States that behaviorism began to lose some of its momentum, and people began challenging the idea that a model that neglected mental processes could actually fully explain human behavior. So this ushered in the era of cognitive psychology, where special attention was paid to language and memory, which led to our understanding of flashbulb memories and tip of the tongue phenomena and working memory and much more. More branching in the 1960s led to humanistic psychology, promoted by Rogers and Maslow, and still prominent in counseling today. We also had cognitive psychology and others like health psychology and industrial organizational psychology, and many, many more. Now we consider psychology to be the science of behavior and mental processes. I've alluded and explained the science side of it a bit, and we'll get into more detail on that soon. But I just wanted to highlight the behavior and mental processes part as well. So behaviors include anything an animal does that can be observed, human or non-human animals. So this is really in line with the behaviorism approach. But we also have mental processes. So this is where the thinking, sensing, and feeling side of the field comes into play. Within this domain, there are a few key aspects that really shape the way psychologists think. The first is known as the biopsychosocial model, or biopsychosocial approach. And this approach connects three levels of analyzing human life: our biology, so our genes, our hormones, brain structure, and so on; our psychology, our thoughts, our feelings, and beliefs; and our culture, or our society, so families, larger society, etc. If you only look at one piece, you don't get a complete picture, even though that's what many historical approaches had done. They looked at only biology or only behavior, for example. We also now accept that cognitive processes occur along two lines, so this is known as dual processing. One of those lines we're aware of, and one we're not. So a lot operates at a conscious level, so we're aware of it, and at least in some control of it, but there's also a great deal happening at the unconscious level. So as I talk about this, I'm aware of the many noises and movements around me, and my brain is evaluating them. I hear birds chirping, a plane flying by, I hear and see my dog walk by, and my brain acknowledges that none of these are a threat, and I can focus on this lecture. Now, I did bring them to conscious processing as I mentioned them, but before that was all just happening on autopilot. Interestingly, there's a nice intersection with the biopsychosocial approach here as well. Had I had different historical experiences or cultural expectations with dogs or planes or even birds, those perceptions may rise to front and center of my attention and really control my processing at that point, which would then distract from the lecture. So remember, a crucial part of psychology and all science is critical thinking. Using common sense or trusting your gut can maybe be an okay starting point, but it certainly does not fall into the category of critical thinking, and it can very often lead us in the wrong directions. So we must rely on evidence to come to conclusions about any questions we ask, no matter how important or trivial they may seem. Three interesting and often experienced situations or findings in psychological science show the limits of over relying on common sense. First is hindsight bias. When Hillary Clinton lost the 2016 presidential election, a lot of political pundits claimed to have seen warning signs leading up to November, despite projecting her cruising to victory just weeks before. So this demonstrates that hindsight bias. When we look back on what's already happened, we can often pick out things to suggest it was an obvious outcome. But before that outcome was a reality, nothing stood out as predicting what's to come. We also often place too much confidence in what we know, or rather we think we know. Eyewitness testimony is far from perfect, and someone's confidence rating in their memory is in no way predictive of how accurate their memory is. We're also overly confident in our ability to predict our own behavior. We say we will do things, we plan on doing things, we have positive attitudes toward particular behaviors, but then we still fail to act. And the final limit that I'm going to cover for our common sense is that we prefer patterns over chaos and randomness. So when we see disorder, we naturally try to explain it in some sort of orderly fashion. So we try to seek out patterns in what is actual randomness. So no, that's not Jesus's face on your toast. It's just a random coloration of the bread as it warmed. Even if it looks like a face, it has nothing to do with the actual person. Part of the reason for this is that unpredictability is unsettling and stressful. If we can explain something, it means we may be able to predict it and have some control over it. That makes us happy and comfortable, so we try to force it even when it doesn't apply. Unfortunately, we've now made it to a point as a society that common sense assumptions and beliefs often override scientific evidence and fact. So we're living in what's known as a post-truth world. Now, this doesn't mean that there's no truth anymore, but rather that there's an overwhelming move to ignore fact in favor of beliefs and gut instincts. So what's gotten us here? There are a few factors that contribute. One, some outlets deliberately manipulate information in order to tell a story that they want to tell, or what they feel is most beneficial for them. Often, the more outlandish and incendiary, the more likely these so-called facts are to spread. So going back to Hillary Clinton here, the claim that she had a kill list and ran a human trafficking business out of a pizza shop. Clearly very incendiary, very poignant. They really paint a picture for you. That's more likely to be repeated. Which then connects to the second factor contributing to this post-truth world is repetition. The more you hear something, the more likely you are to believe it. Part of this is because you remember the content, but you may forget the source of that information. So think back to how many times you've made a claim but then thought, where did I hear that? Or did I read it? And where did I read it? So repetition plays a pretty big role here. Third, similar to the example I gave before, if it's possible to generate a powerful image, people are more likely to believe that statement. So it becomes more available to them. It's more accessible in their memory. And lastly, people gravitate toward other like-minded people. They read stories that fall in line with their pre-existing beliefs. And then they discuss those stories with these like-minded people. So this creates what's called an echo chamber. You're saying the same thing as everyone else around you, and you're reinforcing your belief in that story. So again, that's going to tie back to that repetition and availability. So please fight this trend. I really urge you to avoid over-relying on common sense. Be the critical thinkers that are going to move us forward and out of this post-truth world. So, how do we ask and answer questions in psychology? Since psychology is a science, you should not be too surprised that research in psychology follows the scientific method. It originates at some point when someone has an idea or an inspiration, then they often find an existing theory, if possible, to explain their observations. We misuse the word theory all the time in everyday life. So a theory is actually a statement that explains observations. It's already been supported by a lot of evidence in order to rise to the level of a theory. Einstein's theory of relativity, gravity, is a theory. So there are a lot of examples of theories that you think are actual just facts. So after you've had these observations, you may have a theory to try to explain your observations. Then you develop a hypothesis or an educated guess about what results you will see for one part of the theory, or sometimes the entire theory even, under specific circumstances. Then you're going to go out and collect data in these circumstances and analyze that data to address your hypothesis. Your hypothesis is either going to be supported or not. If not, then you need to modify the theory and test again. If you do find support for your hypothesis, that's great. Now you can actually test under different conditions or replicate it or apply this finding to a less controlled setting. So this process, the scientific method and the research process is never ending. The results you get can feed right back into the theory and new hypotheses, which highlights the value of replication. Replication is absolutely essential in order for a research finding to have value. So what are you more likely to believe? A finding that was tested once or a finding that's been tested and found a dozen times? This has a lot of value beyond just what people are willing to believe as well. So one particular researcher may have a bias and they're trying to support their pre-existing beliefs. The research could be fraudulent, such as the example with supposed connections between autism and immunizations. That's based off of fraudulent research. It hasn't been able to be replicated either. Or results could also actually be driven by just random error from the sampling procedures. So replication helps you lend credence to those findings. One thing to keep in mind here is that a hypothesis is never proven to be true. So just avoid that word. We can support hypotheses, but there's always a chance that it's shown to be incorrect in some future study. The most common types of research used in psychology are descriptive, correlational, and experimental. We're going to go through those in a bit. But before we get there, I just wanted to run through a few important terms for you. So these are all research methods type terms. They're really important for you to know and actually understand in order to understand different types of research. So first is an independent variable. This is the variable that a researcher would manipulate or try to control or change in an experiment. A dependent variable is the outcome or your variable of interest. Operational definitions are how a variable will be measured for a study. This will come up again soon. Confounds or confounding variables are external variables that could interfere with your conclusions. And lastly, we have random selection or random sampling and random assignment. The distinction here is really important. Random selection or random sampling is when you randomly choose people from a population to participate in your study. And then random assignment is when you randomly place people who are already in your sample into different groups for your study. So you may randomly place 10 of your participants to an experimental group and 10 of your participants into a control group. Now that's just 20 people, and those 20 may have been randomly drawn from a population of 100. So that second piece of that would be the random selection. All right, so our first type of research would be descriptive methods, and descriptive research answers what questions? So what is the difference in studying behavior between freshmen and juniors? To accurately describe a behavior or a belief or whatever you're trying to describe, you need a few things. First, the sample in your study has to be an accurate representation of the population you're interested in. So you have to have a representative sample. If you want to answer a question about how much college seniors procrastinate, you really shouldn't be using senior citizens, unless they happen to be seniors in college as well, and in that case, they may not be representative of the normal, typical college senior. So the best way to get a representative sample is to completely randomly select people from the population of interest. Of course, this means actually being able to identify everyone in that population and having a means of contacting them. So to get a perfectly representative sample, you would need a list of every single college senior in the world and then randomly draw from there. So that representative sample often becomes an ideal, maybe not something that's perfectly accomplished. Second, you need strong operational definitions. You need to be very clear in your variables of interest for your study. So again, an operational definition is how you define a variable. So you specify exactly how it's measured or manipulated in your study. This is different from the conceptual definition. So it's not your dictionary definition of a variable. You could define intelligence as the ability to acquire or apply knowledge and skills. That's a perfectly fine conceptual definition, but it doesn't tell you how this construct or how this variable will operate in your study. So instead, for our study, we define intelligence as the sum of participants' verbal and nonverbal reasoning IQ scores on the WACE, which is a common IQ test. Is it perfect? No, probably not. Is it the only definition? No, but it is how we'll be using the term, and that's important because it lets others replicate the study later on using the same definition. That way, if we get inconsistent results, we know it's not because we are using different ways of measuring intelligence. So without clearly expressing that operational definition, future researchers may get different results, but it's just because they didn't know how you measured something. So there are a few strategies researchers could use for descriptive psychological research. The first would be using case studies, where you go into great detail to understand one person or one group of people. They are your case. You hope that the case is representative of the larger population of interest, but that's not always true, so you could get misled by just having a really unique characteristic for this case. Sometimes that's your only option, though. Maybe you're studying a really rare disorder, so you can only have one person. You could also use naturalistic observation, in which the researcher watches people in their normal environment and notes their behavior. You have to be cautious here because you can only observe clear behaviors. So we can't observe intent or thoughts or emotions or beliefs or anything like that. And we're all likely quite familiar with another common tool for descriptive research, the survey or questionnaire, in which you self-report your thoughts, feelings, behaviors, or what have you. Benefits of surveys are many. They're cost effective, so they're pretty cheap, pretty easy, and you can generate a lot of data relatively quickly. And participants tend to be familiar, so they know how to complete them. All right, now having accurately described something, we may notice that two or more variables tend to change together or correlate. This knowledge could then be used to actually predict one variable based on our knowledge of the other correlated variable. A correlation is the degree to which a change in variable A is associated with a change in variable B. We can measure this statistically using what's called the correlation coefficient. And correlation coefficients range from -1 to +1. The strength of that correlation is shown by the absolute value. The direction of the relationship is shown by whether it's positive or negative. So a correlation of -0.5 is equally strong as a correlation of +0.5. They're just in different directions. So when I say direction, positive, so anything from positive 0.00001 all the way up to 1.0 is a direct relationship. So as one variable goes up, the other also goes up. Or as one variable goes down, the other also goes down. So they're changing in the same direction. Anything below 0, but again, only going to -1, would be an indirect relationship. So as one variable goes up, the other one goes down. And again, strength is shown by absolute value. So the further from 0, so the closer to 1 or -1, the stronger the relationship is. You've likely heard it before, so hopefully this isn't the first time. It's surely not going to be the last time, but correlation does not equal causation. So just because two things are correlated, it does not mean one causes the other. So here are some examples of some correlations that you may find. The number of letters in the winning word of the Scripps National Spelling Bee correlates with the number of people killed by venomous spiders, and that's data from 1999 to 2009. Similarly, per capita cheese consumption correlates with the number of people who died by becoming tangled in their bed sheets. The number of people who drowned by falling into a pool correlates with films Nicolas Cage appeared in. And lastly, the divorce rate in Maine correlates with per capita consumption of margarine. So I doubt any of you, or at least I hope not any of you, believe that these variables are related causally, meaning that one change directly causes the other to change. What's likely going on is that some third variable that they are both related to may explain their relationship to one another. So another good example of this would be as ice cream sales go up, violent crime rates also go up. It's not because ice cream causes violent crime or violent crime causes ice cream sales, but they both also increase in the summer. So as weather gets warmer, you see more ice cream sales and you see more violent crime. So correlations can tell us that two variables are related, but we don't know if A caused B, B caused A, or if both A and B were caused by C. So here, just helping you see correlations visually or graphically as well. So which correlation is stronger? You want to look at the slope of these lines. So whichever one is steeper is going to have a stronger correlation. That's this one on top. Positivity and negativity. If it's positive, it's going to be sloping up from left to right. So as one variable goes up, the other one is also going up. The one on the bottom here is negative because as the x variable goes up from left to right, y is going down. Again, which one's negative? Well, this one's going down, so that's the negative, and this one's positive. It's also the stronger one. So you could look at this in terms of direction or strength and figure out those two graphs. All right, so let's say that this top graph correlates someone self-reported animal lover scale and also how many cats they own. So could the researcher conclude that being an animal lover causes people to own a cat? I'd recommend you pause and then answer that. Spoiler alert, I'm going to give you the answer now. No, you cannot say that because this is implying causation. That's not even implying it, it flat out says it there for you. And this is just correlational data, so we cannot make causal statements. This one, it's pretty clear that it's causal, but there are some statements that imply causation. Things like leads to. It doesn't flat out say causes, but that's what you're trying to get at there, so that would be an incorrect statement. And then lastly, we have experimental methods. This is the best way to actually get that causal information. But there are specific requirements in order for a study to be considered experimental. So these three essential properties of at least a well-designed experimental study are that one, at least one independent variable is varied or manipulated. Two, participants are randomly assigned to conditions. And three, all extraneous variables or all confounds that could influence the participants' responses are controlled for. Now this third one is another ideal. You can't really control for every possible confound, but you try to do what you can to minimize those effects. Okay, an interesting quote here that I just wanted to talk about briefly from Kurt Lewin, an accomplished social, organizational, and applied psychologist. He said, experimentation in the laboratory occurs, socially speaking, on an island quite isolated from the life of society. And what he's getting at here is that traditional psychology emphasized the laboratory experiment as the gold standard in research. This is because only lab experiments can really clearly separate cause from effect and explain that causal relationship. But despite this strength, it's also clear that a scientific field that's mainly based on controlled lab studies is pretty lopsided. It may accumulate a lot of knowledge on what can happen under really carefully isolated and controlled situations, but it has little to say about what actually does happen under the circumstances that people actually encounter in their daily lives. So often in intro psych courses, we get so busy thinking about the importance of demonstrating causation and emphasizing those lab experiments that we forget to create a balanced view of psychological research. So we need to avoid that simplistic view that experimental research is the only good or acceptable form of research. So that brings us to some of the limitations of experimental research. First, ethical limitations. As psychologists, we can't manipulate everything in order to determine its effect. If you're interested in whether or not smoking causes anxiety, you would have to rely on a survey or some other non-experimental design. We know that smoking has serious negative consequences, so it would be unethical for us to conduct a true experiment and randomly assign participants to become smokers. We also sometimes have practical or logical limitations. Even if we could ethically manipulate some variables, not all variables are really amenable to that type of change. If you want to know which psychological disorder has the biggest impact on social relationships, psychologists can't possibly randomly assign participants to an experimental condition of having a psychological disorder, just like we can't randomly assign participants to particular races or genders or ages or socioeconomic statuses. And lastly, sometimes there are just realistic limitations. So even if you could manipulate all variables, Does it always make sense to do so? So even in that perfect world, maybe you are going to prefer some different methodology. So a researcher may want to know how often single people engage in certain behaviors. Eating alone in a restaurant, going to a movie alone, sitting at a bar alone. In this scenario, an experiment or a lab study doesn't really make any sense. So there are limitations to experimental research, um, ethically, practically, realistically. Beyond that, there are conceptual considerations that make field research sometimes more desirable than lab or experimental research. So whether you move forward with a lab-based experiment or put together a field-based study, there are going to be trade-offs. So some of the trade-offs can be broken down into different types of validity. Internal validity is the degree to which a cause-effect relationship between two variables is very clearly established. So how confident you are that your independent variable is what's causing changes in your dependent variable. External validity is the degree to which a study ensures that the findings could apply to settings or samples other than the ones that have been studied. And lastly, ecological validity is the degree to which this effect could be obtained under conditions that are typical for what happens in everyday life. So how well have you replicated the real world in your study? The goal for researchers is to try to complement traditional lab experiments with less controlled studies under real world circumstances. So the default for many is to have great, really high internal validity, but in order to do that, you sacrifice ecological validity and to some extent external validity as well. So you can't really have a really highly controlled study, which would be good for internal validity, that is at the same time very realistic, because that's just not the world we live in. So yeah, like I was saying, many studies often compromise, prioritizing one form of validity over another. And then once you put together enough studies on the same topic, you can eventually have several different forms of support. What we've been talking about so far is primarily quantitative based, so it's based in numbers. More researchers take this approach because you have data that are numbers and you can actually do statistics with them. They seem easier to understand. Qualitative research, on the other hand, utilizes data that are words rather than running statistical analyses. You may analyze the words of participants to identify common themes. Qualitative research could be aimed at describing behaviors, generating theories, or other purposes. So it's just a different type of data that you would collect. It doesn't actually have to change the methodologies always. And please notice that I'm using data as plural because data is a plural. Datum, D-A-T-U-M, is the singular. All right, I'm going to be pretty brief here on research ethics. This is a topic that gets covered in a bit more length in research design and analysis, as does the entire research method portion here. But it's still important for you to know the bare minimum about ethics. And just so you all are aware, there are safeguards in place to protect the well-being of research subjects, whether they are human or non-human. For animal research, there's a committee called IACUC, so it stands for Institutional Animal Care and Use Committee. And this committee receives all research project applications that intend to use animal subjects, and they verify their procedures involve minimal discomfort and maximal care in the pursuit of those research goals. In the event that the animals would have to be put down as part of the research, which is often standard practice, their disposal is often required to be beneficial as well. So for example, mice may be given to an owl rehabilitation center or some sort of animal rehabilitation, predator rehabilitation. The Institutional Review Board, or IRB, functions in the same role for human participant research, making sure the subject's rights are protected and that they're fully informed about what they are voluntarily participating in. The last 2 pages of this chapter go over some self-improvement tools. I really recommend reading those pages and thinking about that material as well. Some of this course structure may make some more sense as you read those pages too. All right, that's going to do it for this lecture. Up next is Appendix C, Career Fields in Psychology, followed by Chapter 2, The Biology of Behavior and Consciousness.